Last time, chapter 6, discrete probability distribution. We have number from counting, and then we need probability and the distribution. The time we used the discrete probability distribution. Today, chapter 7, continuous probability distribution. Continuous variable. Numbers from measurement, right? Time, distance, weight, temperature, and so on, right? That is continuous variable, and then using probability, find the distribution, continuous probability distribution. One of them is uniform distribution. Okay, uniform. That means same, the same, right? A value has the same probability occurrence anywhere in the range between the smallest value A and the largest value B. Okay. Example of a playing card. There are 52 cards in a deck of playing card, right? Okay, what is one spade? Probably one spade.
1 out of 52.
1 out of
52.
52. Every card are different, right? So every card's probability is 1 out of 52, 1 out of 52, 1 out of 52, 1 out of 52. So every member of the card probability is the same, right? That is uniform distribution. This distribution is rectangular in shape and is defined by minimum and maximum value. Rectangular. Other probabilities like binomial Poisson looks like curve and right tail, longer right tail, right? But this one, uniform distribution, the shape of uniform distribution is rectangular, defined by smallest and largest. Okay. And then we call this PDF, but for this one just individual members probability. Px equals 1 over b minus a. B is largest and a is smallest. Okay, another example. If our school is big enough, the campus, then school runs shuttle bus from a parking lot to each building or classroom. If that bus run every 30 minutes, then you arrive at the parking lot and then run to the, because you late. So run and then, ooh, bus leave now. Then you miss the bus. How long you wait? Another 30 minutes, right? But fortunately, bus is there and then run and then you catch. And then the bus, after you ride and then leave, 0 minute, right? Fortunately. So, if the bus run every 30 minutes, then output, possible output, 0 minute, 1 minute, 2 minute, 3 minute, 4 minute, up to 30 minutes, right? So time, right? Time, continuous variable. So the probability of 0 minute wait, 1 out of 30. 1 minute, 1 hour 30. Because there are, if we cut by minute, then 0 minute, 1 minute, and 30 minutes, right? So 1 hour 30, 1 hour 30, and so on like that, right? So looks like this. So each minute, each member's probability is 1 over 30 minus 0, right? That is 1 over 30. So each one, 1 over 30. Understood? Okay, this one is my example. Okay, 30 minutes. Then draw a graph of this distribution and so on. Rectangular from 0 to 30, right? And next one, show that the area of the distribution is 1. I told you every distribution, under the distribution, total is 1. 100%, right? So, we can show like this, each one, 1 over 30 minus 0, right? Each one, and then how many? 30 minus 0 is 30, right? So, 1 over 30 times 30 equals 30 over 30 equals 1. The total is 1. Just to show you. Now, how long will a student typically have to wait? Kind of mean. Formula is mean equals smallest plus largest divided by 2. 0 plus 30 divided by 2 equals 15 minutes. Okay, up to 30 minutes from 0. Simply, average is half of that one, right? 15 minutes. And standard deviation looks like this. And calculation 30 minus 0. Largest one minus smallest square divided by 12 always. This one is constant, and then square root 8.66. Okay, next one. What is the probability a student will wait more than 25 minutes? 25 minutes. From this one, formula and calculation for your understand. Draw this one again. 0, 30 here. The question asks you more than 25. Probability x more than 25. If 25 here and then this area, rectangular or square, whatever, right? Okay, what is area of formula? What is area of rectangular? This elementary stuff.
What is a rectangle?
How can you calculate answer? Get answer
2
the
times
area.
length plus 2 times width?
No, not that one. Rectangular.
Length times width? Length times height.
Width times height. Right? Height times width, right? Area. That one, individual probability, 1 over b minus a. This is height times width. B is 30, A is 0, right? Height is always individual probably 1 over b minus a equals 30, 1 over 30 times 30 minus 25, 5 equals 5 over 30. That is 0.1667, 16.67%. What do you think? Easy?
Probabilities are percents.
Either way, okay. Point something or something percentage. Either way is okay.
It's never gonna be over 1.
E over what's that?
Like, it's always gonna be point something.
Always.
Always.
Because the probability is between 0 and 1. So always not 1. If it's not 1, always point something. 0 point something. Okay? Height times width. Next example. What is the probability a student will wait between 10 and 20 minutes? 10 and 20 minutes. We have here, but I will do it again so you understand. Probability is 0 to 30, right? Total. And this one asks you between 10 and 20, probability x between 10 and 20. 10 is here, 20 is here. This area of rectangular height times width, right? Height 1 over 30 minus 0 times width 20 minus 10, right? Equals 10 over 30 equals 0.333, 33.33%. Okay? Questions so far? Practice problem. Just attach it. Question number 4, C and D, not A and B, only C and D. Try. C and D. This area, right? Is height times width, right? Height is 1 over b minus a. B is largest. B minus a. E is largest. A is smallest. And then width.
Thank you.
Okay, let's see. According to the Insurance Institute of America, a family of four spans between 400 and 3,800 per year on all types of insurance. Suppose the money spent is uniformly distributed. This is kind of cool, uniformly distributed. That means rectangular.
Right.
Between this amount, then I ask you not A, B, C. If we select a family at random, what is the probability they spend less than 2,000? Smallest 400, largest 3,800. Then question asks you probability x less than 2,000. So 2,000 here and this area. Then rectangular area of rectangular is height times width. Height 1 over b minus a. B is largest.
2,000.
3,800. This is B. This is A. Minus 400. This is height. Times width of this rectangular. 2,000 minus 400. Equals 2,000 minus 400 is 1,600, right? Divided by 34,000, right? 3,400, not 1,000. 3,400 equals, let me see my answer. 0.406. 7? 0.47 something? Close enough? Good. So 47%.
Do we have to put point whatever, or can we just round to
This
whatever?
one done, okay. If you can kindly. Question? Good? And what is the probability of family spends more than 3,000? More than 3,000. then 3,000. 3,800, 400, 3,000 here, this area. So probability x more than 3,000 equals height and width. Height is 1 over 3,800 minus 400 times 3,800 minus 3,000 equals 800 divided by 3,400 something, right? 0.2353. 2353. And kind, if we are kind, 23.53%. Okay. If combine two questions, C and D, what is between 2,000 and 3,000? Probability 2,000, 3,000. If the question is between 3,000, 2,000 and 3,000, always height is the same, 1 over largest minus smallest. That is 3,400, right? Times 3,000 minus 2,000. 1,000 equals 1,000 divided by 3,400 something, right? Question so far? Easy. I say always easy. Next one, normal distribution. Characteristic of normal distribution. Normal distribution is bell shape or symmetrical shape. Symmetric. That is, this left and right side the same. So that means 50%, 50%. Okay, and then arithmetic, mean, median, and mode here, just the middle, and normal distribution is asymptotic. It is asymptotic. This means as you can see, both tail goes to negative infinite to positive infinite. That means this tail never close to x-axis 0, but never touch for forever. For forever. This one forever, go forever, this one go forever, then they will meet the other side of the earth. Right? Okay. So forever, so never touch. That means asymptotic. The total area always 1, right? Always 1. And shape and position. Normal distribution position changed by mean. Lower mean here, middle and something. And then shape depends on standard deviation. Lower standard deviation make narrow and high. Higher standard deviation make it wider and lower. Normal probability density function. This one is something complicated formula. Individual probability. This one. But don't worry. We will not use this one. Don't worry. If average home page download time is 7 seconds and standard deviation is 2 seconds, what is the probability that the download time will be in 9 seconds? In 9 seconds. Mean equals 7, it says 7. Standard deviation 2 and x equals 9. 9 here and earlier. Because this one asks you what is probability in 9 seconds. In is this way, left side. So this one. The first step in finding normal probabilities is to use the transformation formula. This one is actually individual probability, each output. From this one, we can use this one. So we don't use this one, we will use this one, simple one. So z equals x is 9 minus mu, mean is 7 over standard deviation 2 equals 2 over 2, 1. I call this one z score, or z value, but usually I call z score. Using this z score, we can find probability from the chart. Looks like this. You have a chart, attach it. Okay, first column, z-score. What is z-score? Our calculation. 1. 1, right? if this one is 1.2, if, then 1.2, just 1.0, right? 1. So probability is 1.0, this one, 0.3413. Is that all? No. Look at this picture. These values is only this side. So this 0.3413 is this much. Because this is symmetric bell shape, for the other side is 0.5. So,
How you know that?
because it's symmetric,
Oh, okay.
50-50. So this is always 50, right? 0.5 plus 0.3413. So answer is 0.8413.
0.3413 times 0.5?
Plus. This one from 0.5 plus 0.3413 from this table, right? So I recommend and then suggest draw something like this first. Then find the area. Then plus minus something like that, okay? Good? So in probability x less than 9 in 9, so that less than 9 equals 0.5 plus 0.3413 equals 0.8413, 84.13%, right? When z equals 1, find the area right side plus 0.5 equals 0.8413. Okay? Next example. More than 9 seconds. More than 9 seconds. Probability x more than 9. Seven middle new. 9 here, standard deviation is 2, then more than 9 is this area,
This is less than
more than.
oh,
Okay? Then again, we need a z-score to find the normal distribution area equals x minus mu divided by standard deviation equals x is 9 minus 7 divided by 2 equals 1, right? Okay, from the table, if z score is 1, then 0.3413, right? Point 3413.
So it's the same thing?
Mm-hmm.
It's the same thing as the last example?
Yeah. But this part is 0.3413. And what can be?
You have to.
Total is
The total is
Then total is.
6.
0.5 minus
Yeah, we gotta subtract.
this much, right?
Okay.
Then this one. 0.3413 equals, either way, if you have left side of 9 already, here and the left side, right side we need, right? But you know already left side of 9.
So
Point-
if it's on the left side, you're adding it, and if it's on the
So,
right side, you're subtracting.
This one, total is 1
Mm-hmm.
minus 0.8413, the same. 0.5 minus 0.3413, or 1 minus 0.8413 is the same. Total is 1. This area is 1 minus this much, right?
I got you.
Or only half part, 0.5 minus this much is this one, right? So answer is either way 0.1587. %, right? Little bit complicated one. Not complicated. This one is an easy one. Next one is really complicated. 7 here, 9 here. This area, right? At the same, z score equals 1, right? Still 9, right? Then there was 0.3413, right?
That's just gonna be
This
the
is
answer.
0.313.
That's the answer right
So
there.
34.13%. That's it, right?
Gotcha.
Just to show this one from middle, the table gives the value, that's it, right? But how about between 4 and 9? So drawing I recommend draw and then determine area and then based on that area find. Okay? Seven here, 4 here, 9 here. this area plus this one. So we already have 9, right? Then z square equals 1. From that one, area is 0.341413, right? This much is 0.3413, right? Right?
Yeah.
Mhm.
Now we need this much, right? If is 4, then z square equals x is 4 minus 7, x minus mean mu is 7, standard deviation is 2. That is negative 3 over 2 equals negative 1.5. Negative 1.5. Our table, let me see. There is no negative. There is no negative. That case, just find absolute value 1.5. 1.5 is 0.4332. 4332. So this area from 7 to 9 is 0.3413. From 7 to 4, 0.4332. So
Why wouldn't it be like standard deviation? Why wouldn't it be 3? Don't
standard
you do
deviation
like
is 2.
7 minus 4, it's the same for the whole problem. I thought you got the 2 from like 9 minus 7 is 2.
Mm-hmm.
So when you say 7 minus 4 is 3,
Yes, negative 3. 4 minus 7 is negative 3.
but wouldn't the standard deviation of between 4 and 7
Standard
be-
deviation is always same.
It's always the same?
Yes.
Is it because it's symmetrical? It's always
No, not
2?
that
No,
reason.
it's just the same for this problem?
Mm-hmm.
Okay.
The given standard deviation is always the same.
We're all looking at the same problem, just different places of it. Okay.
So, probability x between 4 and 7 equals from 4 to 7, that is 0.4332 plus from 7 to 9, that is 3413. 3413. That is 0.7745. Got it? Okay or not? So if you if question asks you find between, then find half side from mean, right side, plus find left side negative but absolute value in that area. And add, and that's it, okay? This one earlier, when we cover, maybe it was chapter 2, the display something, then empirical rule. Approximately 68.26% within plus minus 1 standard deviation. Do I have that? Left? No. mean plus minus 1 standard deviation. This area is 68.26%. Plus minus 2 standard deviation. This area is 95.44% by empirical rule. Plus minus 3 standard deviation. This area is 99.73. Have you heard Six Sigma quality control? Six Sigma?
Yes.
That come from this one.
Oh.
Six Sigma means plus minus 6 sigma. What is that area? That is 99.99999999999%.
It goes on forever.
Practice problem number 20. So attach it. Try. First, then I will go over review. Try. Okay, let's see. normal distribution, it says normal distribution, so we use normal distribution. Mean is 29, standard deviation is 5, right? The question asks you between 30 and 34. Between 30 and 34, probability x between 30 and 34. Between 30 and 34. Between question, you need two different z-score. For 30, for